Hello guys, and thank you for joining to this session on the InfluxDays. Today we are going to learn about RESTful API, how to consume, extract, store, and visualize the data with InfluxDB and Grafana. My name is Jorge de la Cruz, and I'm a senior systems engineer for the company Veeam. You can find me as well on Twitter at Jorge DL Cruz. You can find as well my blog on jorgedelacruz.es and jorgedelacruz.uk for the English content. So let's pass to the agenda. We have a lot of things that we are going to discuss today. So let's start with them over. So what are we going to learn? Introduction and quick overview of our RESTful API. We are going to see as well the components and a diagram of the how to do all of this visualization. We are going to do a deep dive in Swagger whenever that's available. We are going to see as well a deep dive on Basel and JQ, deep dive on InfluxDB 1.x queries using Grafana as a dashboard system. That will be our last slides today. So the problems that I've solved by choosing TimeSeries, right? Because we have the APIs already. So why choosing a TimeSeries just to store all this data? Well, the first problem I solve is really where do we want to store all of this data? Do we want to put it on a traditional relational database like MySQL or MariaDB or something like that? I don't think so, because we are going to store a lot of data and we want it to retrieve it fast. So the usual MySQLs or some sort of them, those will not be the best options. As well, the second problem I solve is the time at the end. When I have so many APIs, the time of visualizing all of them, consuming the data from all of them, that can be really time consuming. And that's a problem that I've solved where I put all of this data in a time series database. At the end, I'm just saving time by visualizing later on with Grafana, for example. The third one is knowledge. So at the end, we have so many APIs. Some of them, they are really similar, so we can extract the data with a common knowledge, with a common sort of API calls. So at the end, I've just resolved the uncertainty of the knowledge of the APIs. At the end, I'm just retrieving all that information and saving it into a time series. So I'm just taking a broad set of APIs and saving them into time series. Fourth problem that I've solved is really how to grow and scale all of this. We can start from a really small deployment with InfluxDB. For example, I just have it here on my lab on a Raspberry Pi 4 with 8 gigabytes of RAM. That's fine for a really POC or for a small set of data. But the benefit of time series and the benefit of, for example, of InfluxDB is that this can grow and scale accordingly to our needs. So you can just have InfluxDB in a cluster in an HA as well, or you can just move to Influx Cloud as well and just store all your data there, meaning that this can grow as long as your project grows. So that's really good. I'll say. The fifth problem that I solve is really, as I did mention before, we are storing so many data from so many different APIs. And at the end, I just have one simple dashboard or a set of dashboards where it's showing me the information that I need without going to the different applications, without going to the different APIs. So that's probably the bigger problem that I solve is just visibility across my different applications and APIs. Well, the sixth problem is because I'm a really open source lover, and I really like when the projects are open source, when I can contribute to them, when I can see that the community is contributing to them. So by choosing InfluxDB in this case, that six problems, they went away thanks to choosing InfluxDB. So those are the problems that I've solved by choosing time series, in this case InfluxDB. Let's start with the first point of the agenda, which is the introduction and the quick overview of a RESTful API. So these are really, really, really basic slides. So I hope you are not going to get bored anyways, but we're going to go from 0 to time series. So what is an API? So let's pause here for a minute and then let's start from the beginning. So what is an API? Application Programming Interface. Think of an API as a waitress. You have a menu and then you select some food. The waitress takes that order to the kitchen, who prepares the food, and the waitress delivers the order to your table. Of course, all of this it was on the good old days when we were able to go to restaurants and everything. But again, I hope that this idea, this concept now is much clearer. You can see you are in the left, then the server with the APIs are on the right, and the API is just taking the request and giving us the response. So I hope that is useful for you. A world without an API. Just imagine for a minute a world without an API. That would be a chaos. That would be an absolutely chaos. So imagine you are trying to go for a holiday. Once again, not now, but maybe in a few months' time, or in a year time, or before, even just before. So you're just planning a trip, and then without an API, you will need to go to a website to book your tickets to that place. You will need to go to another website to book the bus tickets. Go to another site to book, I don't know, some attraction tickets or some hotels and so on. That's a world without an API where you need to go to so many different places to do the things because you don't have an API where you can do everything together. Now, I will not want to live in a world without an API, really. So let's talk about a world with an API. A world with an API is much more simpler. You're just there on your smartphone or on your computer, and then you go to a website. Imagine, for example, these websites like Trivago, Last Minute, Booking.com, something like that. And then on those websites, what is happening behind of them is just you're just booking the trip. You're just looking for where do you want to go, the Canary Islands or something really good across the world. And then on that same website, you can just book your tickets, your flight tickets. You can even rent a car from there. You can as well book some attractions and some activities to do. And then you can just book, of course, just a flight to come back. That from the one very website. That website, of course, is doing a lot of calls to the rest of the to the rest of the sites. So that is a world with an API. That's a quick example, but everything that you are using today is using APIs. Think about Twitter. You're just there checking your Twitter. Twitter is a big site where behind happens a lot of things like the delete messages. Probably that's an API. Adding an images, the images are querying another CDN site from Twitter. Or if you think about Facebook, that's probably a better example because it has so many APIs. Every single application that you see inside Facebook, that's a mini site, a mini endpoint, a mini API at the end. That they are all of them talking between them and showing you all the information that you want to do, your likes, the picture of your friends, news, videos, absolutely everything. So that is a world with an API, and it is a much better world if you ask me. So what is a REST API? Is just the acronym is representational state transfer. REST, it's an architectural style based on web standards and the HTTP protocol. So we will discuss much more about that on the next slides. Everything is a resource. So everything that you can get from an API is a resource that you can just get, delete, and so on. But we will discuss much more about that later on. You can just take it and include or HTTP methods, and is a server client model as we discussed on the beginning of this presentation. So let's move as well. HTTP methods. We said that a RESTful API is just it's kind of based on these HTTP methods. So the most popular protocol use the RESTful APIs is HTTP, as I did mention. So the REST architecture uses HTML verbs to make requests. So you can just, for example, do some of these. It's not on all the APIs. So every API, it has their own different ways of giving you the data or allowing you to interact with the data or with the endpoints. But the most common ones are get, read data or resources, and I'm using, as a part of this whole project, I'm using the get in absolutely all the APIs that I can. So I'm not doing much post at all, which is going to just create data or resources, but the post, it's really important for those out there doing automation, just introducing data through this post. For example, delete data or resources that sometimes you don't have enough access to do the delete, for example, neither the post or, for example, the put, which is going to update data or resources. So as I did mention, as a part of this whole session today, we are going to focus much more on the get, which is just read the data from the HTTP and then saving it into InfluxDB. So what are the response status that we can get doing all of these queries? For example, the get on an API. They are quite simple, and probably you know this already because you have seen them, right? So, for example, if you get a code after running the query of which is 100 or 101, 102, on the hundreds, that will be informational codes. If you get them on the 200, that will be successful codes. Those are the codes that we are looking for after we run a query. It's much better that we get a 200 and or any other into the 200s. That will be good successful codes. If you get a 300 something, 301, 302, 3, that will be redirection codes, meaning that you probably it will end up on a successful code, but your query had been redirected to another API or to another site, and so on. If you cannot get for example, the website, all of us, we know the 404 error. So that will be client error codes. And finally, the most difficult to troubleshoot sometimes is just getting the 500s. If you get a 500, that will be a server error code, and that will be really difficult to debug sometimes, but you can just guess that it's just some server error code. So they are quite simple because all of us, we have been using web browsers for a long time, and sometimes we have get some of these errors on the web browser, like the 404, for example, is the most known one. So they are exactly the same. We are going to query via HTTP the APIs, and we will get these errors over here. So, okay, talking with an API. It's different ways where we can talk with an API. For example, the most common way of doing it is using Postman, for example. Before it was a Google Chrome plugin. Now you just need to download a standalone. Postman is one of my favorites because you can just add your own libraries or download libraries from different sources. So that's a good one. If you use Mozilla Firefox, you have the REST client as well, just to do some queries to these APIs. You can use Swagger when it's available. So if the application or the software or the machine, if it's exposing an API and the developers, they bother to add the Swagger, that's much better because that will allow you to interact with the API natively directly within your browser using Swagger. We will discuss much more about that later on. So, and finally, it's the curl for the command line gig. We will use curl later on the bash shell scripts that that I'll show you. So, but these are the most common ways of talking with an API, really. So let's pass to the next slide. So let's discuss about the components and the diagram of the how-to. We are going to comprehend everything by seeing it visually on a diagram. This is quite simple diagram. We have the RESTful API or all the RESTful APIs that we can get, so different applications, different softwares, and so on. Then what we have is a bash shell script, which I'll show you then later on as well. that script is going to interact with the RESTful API. Probably first is going to authenticate, and then after the authentication, we are going to run our queries, and then we are going to send all of that data directly into the InfluxDB server by using the InfluxDB API as well, but in this case as a post. So we are going to write data directly into the InfluxDB server from that Puzzle script. So that the Puzzle script, it just takes data, just takes information, and then it just pushes the information into the InfluxDB server. What's the last step? The last step is going to be, we have Grafana for visualization, but we can have chronograph, for example, as well, or any other dashboarding that it reads from the InfluxDB server. And then on the Grafana, in this case, we are going to have we are going to create our own dashboards, or either import the hundreds of dashboards that they are already available for this purpose. So it is quite simple, and we will see a few examples of all of this much later on. So let's discuss now about the deep dive in Swagger. It's not always available, but when it is, it's the best resource. So sometimes some softwares they expose the API out there, but the API is not exposing the extra Swagger, so we cannot interact with it itself. But in this case, we can do it. So let's take a quick look into what we can do when you have Swagger. So as a part of this example, we are going to see how to interact with this API. First of it, we just go to the API, to the HTTP that the software tells us. We are going to authenticate. In this case, I'm going to put my username and my password. Okay, it's giving me a token, and you can see that it's giving me 200. The response code is 200. So everything went well. We took the bearer here, we put it, we authenticate. Now we go to the backup repository endpoints. We click in try it out, for example, and then here we go. We get the information that we need. In this case, is for this backup repository, so we can see the space, we can see the ID, and so on and so forth. So that's a good example of a RESTful API. And now we are going to dig a bit more. So we get this information, right? This information is great. It's giving us a JSON, and this JSON, it can be bigger or smaller. It depends, of course, of the API and the application and so on. But in this example, just think about this example. We have the ID of the object storage. We have some cache path, if the encryption is enabled or not, encryption key ID, a lot of things on the JSON. But some of them, they are not important for me at the end. I don't want to extract those and put in InfluxDB because they are not relevant for me. So the only ones that I want on this case is just the object storage ID, storage cache path, the capacity bytes, free space bytes, ID, and name. Those are the only ones that they are important for me, and the ones that I want to save into my InfluxDB. So later on, I can build a dashboard around that. And this is just a simple, quick example, okay? So let's take a quick look now into the deep dive on bash shell and JQ. JQ is the set, if you know set for Linux, it's just the set for JSON data. At the end, the goal is to parse in like a pro, really. So let's take a look now into how we can parse all of this using JQ, right? So we have on the left the JSON data that we obtained on the previous slides, right? That we obtained from our API, and remember, it's a lot of information that we do not need, we do not want, and it's a few information that it's relevant for us. So if you are not a guru in how to extract all of this data and how to parse it, I am not one of them. So I always go to jqplay.org, and then I just copy paste there my data. Once I have my data, then is when I start to play with the parsing. For example, on this case, remember, I just wanted the object storage ID, the cache path, and then I want the free space, and so on and so forth. So the JQ, it will look like that. So it's JQ, and then is dot, then you just go inside the loop, and inside the loop you just want the object storage ID, cache path, capacity bytes, free space bytes, ID, and name. So it's not that difficult to build to use JQ, and it's not that difficult to parse JSON data. You just need to know how to jump inside the loops, and then which information you want from every loop, because usually the JSON they have loops, and at the end you just need to retrieve the information. So this is the example that I was mentioning before. This is what is going to be relevant for me. Okay, so now that I have the JQ, how to parse it, right? Let's take a quick look into how all of this is going to look like finally on a bash shell script. It's not difficult. I know that you can see here a lot of text, and maybe some of you are afraid. Maybe some of you they are following the session, and it's quite simple for you. So let's take a quick look for the ones that are having questions around all of this. So we start from the beginning. We can see that it's just a bash shell script with a lot of comments over here, which is always good for people to understand what is this script about. Then we have some endpoints for the InfluxDB that we need to fill out, and then some endpoints and variables for the RESTful API. So, and then here you can see that on the Vim bearer, what is doing this is just doing a API call, a curl to the authentication website, the API, the authentication API with the username and password, and it's giving us the access token. So with that access token, then we can build, and then we can keep constructing and building this the bash shell script. So now that when we have the bearer over here, now we move to the next step. So the next step, for example, it was remember that backup repositories and remember what it was important for me. This is the command. This is the how it looks like in a bash shell script. So what I'm doing on the line 137 is just kind of building the API URL that I want to query. On the next line, I'm just calling, so using the get. I'm just getting the information from that API using the authentication token that I get on the previous slide, and then I'm saving all of the result on this Vim repo URL. So on that variable I'm going to have the whole JSON that is giving me the information. So that's good. I have the JSON already. It can be bigger or smaller into this variable. What I'm doing later on is just I just parse this JSON with information that I need. Instead of taking just everything with one line, same as we did with the JQplay.org, I'm just doing it, saving every single variable that is important for me into an individual variable, right? So I'm just saving the repository, and you can see that I'm just going into the array, and then into the array or into the loop, and then I'm just taking the name, I'm taking the capacity bytes, the free space bytes, and the object storage ID, and if the object storage encryption is enabled. So once again, all of this is exactly the same as we have done with the JQplay.org. So I'm just parsing a JSON and saving it everything into the different variables. So what is the next step? Now we have all of this data, and then the next step is writing this data into the InfluxDB. To saving it into the InfluxDB, quite simple. You do the curl. You do in this case the post, because you want to write data into InfluxDB, and I'm just saving it into InfluxDB 1.x format. So which is just the name where you want to save it, and then the different information inside the measurements. So it's that simple. And you can see that everything else that is happening is just repeating all of this, but for different URLs. So once again, what I wanted to show you today with this example is that you can use this very bash shell script for absolutely every API that you have out there. First, you will need to get the authentication token, most likely. Then after, you just need to build the URL that you want to query. And then last is you query that URL using the authentication token, save the JSON data into a variable, and then you parse it as you like. What is important for you, then you save it into variables, and then after that, you write the data into InfluxDB. Why am I saving all this information into InfluxDB? Well, it's sometimes the APIs they cannot have all of the data, or if the data is really big in terms of you have a lot the API. If you're querying, for example, something that is, imagine backup jobs, for example, and you're trying to get a backup job from a year ago from an API, and you are doing this hourly, for example, that can be really heavy in terms of the server to give you that API result itself. So for those use cases, it is much better you just query a time series database, which is going to give you that information within seconds or within milliseconds. So at the end, a time series database is purpose built for these scenarios, right? Where you want to retrieve information not just from the 5 minutes ago, but from week, month, from a year old, and also you want even to get all the endpoints, all the points for between today and 1 year old. So it's much better to extract the data from the API and save what is just important for you into InfluxDB. So I hope that this example with the bash shell script is clear for you, and hopefully you can reuse it to build your own, to build your own dashboards, to build your own workflow that we have seen at the beginning, which is just any API, parsing it with the JQ, which is using in this bash shell, and then finally pushing the data into the InfluxDB server. So okay, let's move to the deep dive on InfluxDB 1.x queries using Grafana. So how to quickly build gorgeous yet useful dashboards. And then, for example, is the Grafana quick overview 1. So for example, once again, query the data in InfluxDB is quite simple, either on Chronograph or even here on Grafana. It is quite simple. This is just InfluxDB 1.x, remember, it's not the 2.0. So what do I have here? So the from default, from this specific table, I'll say, then just where the Vim job name is some variable, which I'll show you the variable in the next slide, then give me the total duration, give me just the mean, and tag them by Vim job name. So, and I'm going to alias them, combine them by the Vim job name, just to show you that, just to show that name on the diagram. What this simple query gives me? Well, it's giving me that I have all of these backup jobs, right? And it's giving me the duration in seconds or that every backup job is taking. So it's quite simple, it's quite beautiful, really useful, of course, because if you want to know which backup job is taking more time than other, this is quite simple to visualize it within a time series, right? So that was a simple query. Let's take now a look into a query that instead of using the visual Grafana builder, I'm using just text itself, just the whole query on here. It's quite simple as well. I'm just taking the last capacity and the last free space. I'm just doing here a mathematical calculation, and then I'm just giving that and saving that over here. So it's giving me that the cache NTFS repo 1 year it has this average, the 5 years has this average, and the S3 repo has this capacity used. So it is really simple. Once again, maybe this is a bit more advanced example, but anyways, I wanted to show you just in case that all of this can inspire you to build your own. Dashboard variables. So either in Chronograph or either here in Grafana, you can use these dashboard variables. And what this does at the end, you can just create, for example, into the settings of the Grafana variables, you put the name, you create some label, and then this is a type query. And in this type query, you are going to see like show the tag values from the Vim Office 365 jobs. So this with the key Vim job name. So this is going to give me all the jobs that, of course, they have the Vim job name. They are going to appear here, you see, like this Blog UK, Exchange, OneDrive, SharePoint, Teams, Job 5, 6, 7, and so on. So that's great because later on I can use that variables if I want to use them. I can use those variables over here, you know. So when you are selecting on the top of the dashboard, you can select whatever you want to see and build the queries. The queries later on, you can just build them using these variables. So in this case, for example, if you just want to get the information for only one server or for only one backup job, it's quite simple to get from these variables. And that happens for everything else. For example, I have a variable for the jobs, but I have as well another variable for the organization, backup proxies, repo, object storage, and so on. So if you have, for example, if you are building a huge, massive new dashboard with different data sources, different APIs. At the end, the data source is going to be InfluxDB. Different APIs you are saving from different APIs into the same InfluxDB database, and even into the same fields. Because imagine that the applications, they are quite similar, and you just want to get, I don't know, like customers data or some sort of response of the server, how much time is taking. You can always just create the variable for those different APIs, where it's going to be application 1, application 2, application 3, and then later on show them here and filter them per application. So you can just be really granular later on. So once again, all of these are examples that I hope that they will be useful for you. So now I wanted to keep showing you more examples. This is another example, in this case with the white template of Grafana. And in this case, I'm reading another API, completely different API, in this case for another product, which is called the Vim Backup for Azure. So I'm just taking from that API, and it's giving me different data. It's giving me, for example, the Azure region where I have my VMs running on or my instances running on. Is giving me as well on the API if they are protected, if they are not protected. It's giving me the version, the workers, and so on. And of course, the job duration, as you can see over here. Those one is one of my favorites, just to put the bubbles, and how much time that did it take. But in this case, what I use is another Grafana plugin, which is showing me in the map, is showing me the coordinates for in which data center I have VMs that are not protected. Once again, these are just examples that I hope that they will be useful for you, just to build your own dashboards over there. So what else do we have? Well, we have another example on here, and then, for example, on this one is the same that we have seen before, the Vim backup for Microsoft Office 365, but we didn't have a chance to look it inside the dashboard itself. So what I'm doing over here, I'm just cloning per backup job all of these fields, and is giving me if the last result was a warning or a success or a failure, and I'm doing that not by text but by numbers. So I'm just taking if the job was a success, that's a 0. If the job was a warning, that's a 1, and if the job was an error, that is a 2. So I'm saving on InfluxDB 012 as a Vim result, as a job result, and then I'm just converting all of that into warning, success, or fail later on in Grafana. So that's another example. That's another quick tip just for you guys, how to get these things really good. And of course, I'm just saying that if it's a 0, the whole field is green. If it's 1, is kind of amber or orange, and then if it's 2, then it's red. So that's a good example. And as you can see over here, once again, the job duration. This is one of my favorites that I absolutely like, and yeah, it's giving you the job duration on this sort of bubbles, on these sort of dots, and it's super easy to see which job is taking more or less time. So now moving to one of the most advanced dashboards that I built over this time, reading from an API once again, is about this Vim Enterprise Manager. This is a huge, massive API, It doesn't have a Swagger, so it's quite difficult to query and get the data from all of this, because you just need to keep doing curls and then getting the data and so on. So it doesn't have Swagger and it's a bit more difficult. But once again, as long as you know the JSON that is given to you, you just go to the jqplay.org and then start parsing your data. What is important for you? What is not relevant for you? So in this example, for example, the summary, I wanted to know how many backup servers do I have, repo servers, proxy, VMs that are protected, VMs that are not protected, the storage capacity per data store. I really like this new kind of Grafana in Grafana 7. I think this came or probably even before, this really old LED sort of things that reminds me of the DeLorean or the Back to the Future. Reminds me that those these colors and so on. I really like that as well. And what I've done here different that you can maybe take or borrow some ideas is about the job status. This is just per job, and as well I have it per VMs, but I'm not going to show you. And is if I have 100 jobs or 50 jobs or 25 or the number that I want, once again, that's 012 that I showed you before. And now I'm cloning that per job. So every job is going to appear here with the latest status of how it was. So all of this is just to take some ideas, just giving you some thoughts. For example, on the next one is still the same dashboard, so it's really massive dashboard. And in this case, the job duration as per usual, because you know I like this, I say that already. But in this case, I put the job historical information as well into a table, so if they were okay or not. And in this case, I'm changing the 012 that I did mention before for this sort of emoticons that you can just put here. So you can use in Grafana, you can use as well the icons that you can just copy paste and they will show you, they will show them like here. And for example, another table, super quick table, really simple, but this is important for me. So the backup jobs and what's the content of these backup jobs. All of this, I'm just getting it from a RESTful API and I'm saving it into InfluxDB, in this case, as a tags. So all of this, is, hopefully they were good examples for you. And remember, all of this is just by reading an API, parsing it with JQ inside of a bash shell script, and then within that bash shell script, I'm just writing this data directly into InfluxDB, and later on reading it finally with Grafana. So we are at the end of the presentation, I'm afraid. Hopefully it was useful for you. Before we go, I wanted to show you another alternative that you can do where you can just get information from a RESTful API directly. In this case, it's not sending any data to the InfluxDB, which of course, it kind of defeats the purpose of this whole presentation. And I really like to get the information into InfluxDB just to query the data much faster, and just to query the data if I lose the application, for example, and I want to query the data, then you cannot do it. So once again, much better you just take the API information, saving it into InfluxDB, and later on query your InfluxDB. Anyways, in the case that you want to go directly from the API to Grafana, this is an example which is a plugin that is still not for production ready. So please don't use it in production, just maybe for your tests. And it's called JSON API plugin. It's by Marcus Olson. And this is what I did mention at the beginning of the slides around community, around open source, right? That you always you can always learn and test new things that the community are doing around. So this is one example. If you want to test it directly from an API directly into Grafana, but still, I really think that there are a lot of reasons for you to do it from the API to InfluxDB and InfluxDB showing it to Grafana. So without any more delay, thank you so much for joining this session today. Thank you so much for being there, this around 40 minutes session. And I'm just here to answer any question that you might have. So I'll show you on the text, and I will keep replying to you to all your questions. Thank you so much, and see you soon.